Okay, we got cut off last time, so just want to kind of cover the very last section of this section. It's called the checked and unchecked exceptions. So basically, an unchecked exception is the one that runs under the error class. So kind of getting back to this diagram. So the unchecked are the ones that fall under this error category, and those are going to be things like out of memory exceptions. Those are things we cannot fix. So those things fall under this. Those are called the unchecked. The ones that are exceptions, the ones that we can capture, are called the exception. Those are the checked class, the checked exceptions. So unchecked and checked. So when we hear the term unchecked, we're basically talking about errors that we cannot capture, and checked are ones that we can capture. So kind of so getting to this new section called throwing exceptions. So kind of what we've done so far is I want you to think of it this way. We have tried something, and when we get an error, it catches that error. But the only way we can catch a ball is someone has to throw it first. So when this system gets an error, it throws an error, and then we have a try catch, and our catch statement catches that error, takes over from there, and goes on. So one thing that we can do, we can actually manually throw an exception. So what we've seen so far are automatic, where it basically does a catch, and behind the scenes it's doing the throw. So, and here's a great so another thing we do is we can create our own exceptions. So if we look down here, we've got throw new exception out of fuel. So let's say we've written a car class, some kind of a vehicle class, and we basically have it go so many miles, and every time it drives a little bit, we take a little bit of gas out, just like a regular car would. So we'd have a program that does that. Well, if we don't refuel, guess what will happen? We'll eventually run out of fuel, and we can actually then create what's called a out of fuel exception, and then throw that exception, and then our catch statement will catches that, and we'll basically execute that. So let's see if they have a good, okay, yeah. So take a look at this date component exception demo. Okay. So here's our date component. Well, first of all, let's so first thing we have is we have a date component. Okay, and just a normal class. You notice it doesn't have a public void main. That means it's not executable. We have to create an object from this class in order to use it. So here we have the public class date component. We have 3 instance variables, month, day, year. They're all 3 strings. And then looks like we have a constructor. So here's my date component constructor, and it's expecting a string. So if I instantiate an object from this class, I will need to provide a string of data. And I believe it is expecting, because it's using a string tokenizer, I believe it is expecting the first 2 characters to be month, the next 2 to be day, and the next 2 to be year. So you'll notice that right off the bat it says if date string, so whatever we're receiving in this constructor, if it's equal to null, then we are going to throw. So we're taking a ball and we're going to throw it to the other side. Now, to be able to get that throw, we have to have a catch. So, date component. I have to go back and look to see what the main is going to be for this. Account test. Okay. No, that's not right. Date component. Oh, come on, I just did this. Right, let me take a look again. Um, oh, here it is, date component exception demo. Okay. So here's the date component exception demo, and here's what we've done. I created a variable, it's a string, it's called str, and I initialize it to null. And then I say try. I create a date component class object called DC. So I now have a date component object. Then I instantiate it as a new date component, and I pass in the str. And I say system out, get month, get day, get year, and if they're valid, it's going to go ahead and print them. Else, if an exception is thrown, it's going to catch it as an illegal argument exception. And it's going to basically create a class, an illegal argument class object called E, and we are going to display that message. So again, we are passing a null. If I come back over here, it says if it receives a null, it's going to throw an exception. So it's going to throw that, and this guy is going to catch it and display that message. Okay, so if I run it, null reference passed to date component constructor. So we did catch the exception, and we displayed the message that went with that exception. Now, if I happen to do something like this to make it valid, I could have done and when it ran right there, it would printed 10/31/2015. So it basically worked just fine. So again, we can throw an exception. I can say if I receive something that I feel is an error, I can throw that exception and actually manually kick off the exception process. So what we've seen at this point is we've seen the system automatically take and capture those errors and then deal with them. This is a time when we are going to actually catch it ourselves and throw the error. Okay, so we can also create our own exception class. So far we've seen out of bounds exception, we've seen the format exception, so we've seen a few of the automatic exceptions that are out there, ones that are built into the exception class. We can also create our own. So if we look, here I have a class called negative balance starting balance. It extends the exception class. So it says I want everything that the exception class has, and I'm going to provide a little bit more. So this is our exception class, and the first thing it does is it has two constructors. It's got a constructor with no arguments called a no-arg constructor, and we've got one that has a double. So the signature for that is a double. The signature up here is nothing. They have the same exact name. They can do that because they're overloaded. I can overload a method as long as I have a different signature. And what's inside the parentheses is the signature. So if I pass this nothing, this guy will automatically execute. If I pass it a double, this one will automatically execute. So if I get an exception and I basically utilize this exception class, it will basically, now notice it says super. That means it's going to call this exceptions class constructor, and it's going to pass this string. So it passes a string to the constructor of the class it's inherited from, and that guy then probably has some way to display that message. It will display this message somehow. Okay? So here's my bank account. So here I have this account test. So here's what I do. I try to create a bank account object called account, and I instantiate it as a new bank account, but I'm going to pass in a negative 100. Okay? I've got a catch statement. Notice it says negative starting balance. That's that class we just looked at. That's this class. So we create an object from that called E. We create an object from that called E. And then we display a message. We just go ahead and display the message. See where it says get message? Well, where is get message at? It's probably built into the superclass, and that get message will automatically display the message that's passed to it, which probably is this, what's inside these parentheses. So we go to bank account. Here is our class. Here is our instance variable. It's balance. It's a double. Here I have a constructor. It's a no-R constructor. I have another constructor that's overloaded. This is accepting a double. I have a third constructor, same exact name. Its signature is a string. So I have three constructors of the same name. One has none, one has a double, one has a string. So three different signatures. That's how we can overload. Notice that this one that receives a double says throws. Throws a negative balance, negative starting balance. This is that class we created. It says if the start balance is less than 0, throw new negative start balance and pass the starting balance to it. So it instantiates a brand new exception class object called negative start balance. We pass it that balance, and then I say balance equals start balance. Now this line will never get executed if this guy is true, because it will hit this exception and basically get out. So if we go ahead and run this, we can see it says error, negative starting balance. So we can see that message that that exception class that we created happens. So the whole point of this is we can create our own exception with our own messages, and then we can throw an error and accept that, or make that exception basically take on that particular error process that we want it to do. Because some of those are pretty generic, like the divide by 0. I believe it's some kind of a number formatting thing, but it kind of has its own messaging things. Well, if we want a specific message, in this case error negative starting balance, we can do this. Create our own exception class and basically throw an error to it. It's really a very neat, powerful process that allows us to, again, when the user does something wrong, instead of the program blowing up that we've seen in the past, we capture the error, give it the control back to the user, and say, hey, you need to fix this to continue on. We have this thing called the @exception tag. Again, if you remember, I believe you have to look it up in the index, but there is the Java doc, and the Java doc will allow us to create automatic documentation for our code. Well, if I come over here to bank account, notice all of our Java documentation starts with / and ends with */. And this information will automatically be included in the Java documentation. So right here I've got @parm as the start balance. This is the code that says this is a parameter that's brought into this particular method. Then I've got @exception. It will automatically document the exception information for this class because of this little tag right here. And it will show the exception class that is being utilized. So it automatically documents all of this. If you come up here, I can't get it to work on home, but I've gotten to work, I believe, in school. If you click